So now, dear student, let's start another topic of the chapter. Topic is equation of motion in a plane with constant acceleration. Now first of all, equation of motion means what? Equation of motion means what? Generally, if we discussed about the motion, for example, if anyone asks you to write an essay on a Rajdhani Express, so during the explanation, which physical quantities are involved in the essay? For example, Rajdhani Express, the good train, arrival time, departure time, time is involved in the discussion. Second thing, it performs the motion with what velocity, what is the speed. So velocity is also another physical quantity. Third thing, it travels how much distance, displacement, path length are the another physical quantities. So in short, equation of motion means equation of displacement, equation of velocity, equation of acceleration, time. So during the motion of any object, these physical quantities are involved like time, displacement, velocity, acceleration. So equation of these physical quantities are known as the equation of motion. But here we will discuss the two-dimensional motion. Motion in a plane. Motion in a plane means we consider that object performs two-dimensional motion. Along with that, also we consider one condition that during the motion, acceleration of an object is constant. Okay, let's understand with the help of diagram. For example, suppose this is y-axis and this one is x-axis. Okay, so this is xy plane. Okay, now randomly we choose a random path on which the object is travel. Okay, suppose this is the path on which one object is travels. Look at the path. We can say that it performs two-dimensional motion because of during the motion x coordinate will be changed and during the motion say y coordinate are also changed. So here we consider roughly a path on which one object is travel. Okay, now let's assume that initially object is here at a point at time t is equals to 0. At time t equals to 0, object is at a point and from this point it starts the motion with velocity v0. So v0 is actually known as the initial velocity. Object is at a point and from that point object starts the motion with what velocity? With velocity v0. So v0 is known as the initial velocity. Now suppose after some time object reach here at b point. Suppose at time t equals to t, object is now at b point and here at b point suppose its velocity is v. So we will call it v is the final velocity and v0 is the initial velocity because we just discussed the motion from a to b. So in a to b, v0 is the initial velocity and v is the final velocity. Definitely so many things I am going to add in this diagram, but right now v0 is the initial velocity and v is the final velocity. v0 is initial velocity and v is the final velocity. Okay, now we know that acceleration, now acceleration, I'll write in a short, acceleration is equals to change in velocity upon time. There is a familiar equation you all should know in 8th, 9th or in 10th standard you already know the equation like velocity means displacement upon time, acceleration means change in velocity upon time. Acceleration means change in velocity upon time interval. Since acceleration is constant and there is a vector quantity, so we have to put an arrow above the symbol. Achha, now change in velocity, student, change in velocity means final velocity minus initial velocity. Final velocity is v minus initial velocity, v0 gives us change in velocity, and denominator there is a time interval. So look at the diagram, object is at A point. Tell me it will take how much time to reach from A to B. So we can say easily at time t equals to 0 object is at A point, and at time t equals to t object is at B point. So it will take t time, t to reach from A to B. Let's call it equation number 1. We can write in this way also, v minus v0 is equals to at. This t I will take in the left hand side in the multiplication of A. Now this equation can be written in this way, v equals to v0 plus at. So this is the equation of motion, call it equation number A. V equals to v0 plus at, where v is the final velocity, v0 is the initial velocity, a is the acceleration, and t is the time. So see, here we will get one equation. But now, dear student, I am going to tell you one most important thing. Actually this chapter is the chapter of motion definitely, but we will discuss motion not in a one dimension, motion in a two dimension. Always remember one thing, I'll give you few points you should remember, keep in your mind. If anyone asks you during the motion at any point velocity is in which direction, for example, I'll give you one example. Suppose one object performs circular motion in an anti-clockwise direction. During the motion when particle reach here, now if anyone asks you that at this point velocity is in which direction, so always remember during the motion at any point velocity is in the direction of tangent drawn at that point. For example, when object reach here, here its velocity is in the direction of tangent. When it reach here, here its velocity is in the direction of tangent. In short, tangent drawn at any point gives the direction of velocity at that point. Always remember, tangent drawn at any point gives the direction of velocity. So for example, here from A point object starts the motion with velocity v0, where v0 is the initial velocity. So it is very clear from the diagram that okay, we also know that if any vector is like that, so this vector has two components. Suppose name of the vector is v0, so this vector has two components. This is the x component which is v0x, and this is y component which is v0y. So velocity has two components. So if you would like to write this equation in terms of its component, like we know that v is the final velocity, but it has two components. v0 initial velocity, it has two components. Acceleration maybe has two components because object performs two-dimensional motion. So if you would like to write this equation in terms of its component, so it can be written in this way, like x component of final velocity is equals to x component of initial velocity plus x component of acceleration into t. Similarly, y component of final velocity is equals to y component of initial velocity plus y component of acceleration into t. So this equation can be written in terms of its component in this way. So remember, this is the equation of motion. Okay, let's derive another one. Again come in a diagram. Now initially particle object is at A point. Okay, with respect to origin, this is the initial position vector. Let's call it r0. r0 is the initial position vector. This is also position vector. Let's call it r is the final position vector. Also we assume that when particle is here, object is here, here definitely it has some coordinate, like here suppose x coordinate and y coordinate. So suppose initial coordinates are x0, y0, and when object reach here, here its x coordinate and y coordinate are assumed to be xy. So x0, y0 are the initial coordinates and xy are the final coordinates. Okay, where r0 is the initial position vector and r is the final position vector. Okay, let's move forward. Now, as you know that acceleration means change in velocity upon time. In the same way, average velocity is equals to So we know that velocity is equals to displacement upon time. Displacement upon time gives us average velocity. Okay, we have two velocity, one is initial velocity v0 and one is final velocity v. Let's assume, suppose average velocity is v plus v0 by 2. How it came? So dear student, you all know that in the language of maths, suppose two figure is given to you like 2 and 4. If anyone asks you take the average, so average means 2 plus 4 by 2. In denominator, the addition of observation divided by number of observation gives us the average. So similarly here we have two velocity, final velocity and initial velocity. So average velocity we assume that v plus v0 by 2. Now in the right hand side displacement, look at the diagram. This is the initial position, this is the final position. So this is displacement, let's call it delta r is the displacement vector, let's call it delta r. And as you know the time interval is t. Okay, so from this equation delta r is equals to v plus v0 by 2 and this t will shifted in the left hand side in the multiplication, let's call it number 2. Okay, now please observe carefully. I am going to simplify this equation. Delta r is equals to, okay, divide by 2 as it is, out of the bracket t as it is, v0 b as it is, plus sign as it is. Now this v, as we derive this equation, v is equals to v0 plus at. So let's put this value, v is equals to v0 plus at, v0 plus at. Now multiply this t in bracket and open the bracket, so we will get this equation. See, v0 plus v0, 2v0 into t, 2v0 into t, plus at into t means at square and divide by 2 as it is. Now separate the denominator, so it gives you this equation, v0t plus half at square. This is the equation, another equation of motion, let's call it number B. Delta r, actually delta r is the displacement, delta r is the displacement. This is the equation of final velocity v0 plus at, this is the equation of displacement delta r equals to v0t plus half at square. Okay, now come here. As I said earlier, this equation can be written in terms of its component in this way. So in the same way, this equation also can be written in terms of its component. Now here it's most important thing. Achha, this equation also can be written in this way, delta r displacement. Displacement means final position minus initial position means r minus r0. Final position vector minus initial position vector gives you displacement vector v0t plus half at square. So the above equation also can be written in this way. Now question is how to write this equation in terms of its component. For example, look at here. Suppose this is y and x axis. As in this diagram, let's assume one path. Chalo, initially object is at a point. Suppose here its coordinate, x coordinate is 1 and suppose here y coordinate is 5. It means that initial coordinate x0, y0. Initial coordinate x0, y0 are 1 and 5. After some time particle reach here at B point. Suppose here its x coordinate is 7 and here its y coordinate is 4. So it means that here the final coordinate xy coordinate is 7 and 4. From this diagram, if anyone asks you, okay, by object performs motion from A to B, it makes how much displacement particularly in x direction? So it is very clear, initial x coordinate is 1, final x coordinate is 7, final x coordinate minus initial x coordinate gives you x displacement. So here it is very clear that x displacement is 6 and y displacement is, initial y coordinate is 5, final y coordinate is 4, so y displacement is 1 but in a negative downward direction. So in short, final x coordinate minus initial x coordinate gives you x displacement. So agar if you want to write this equation in terms of its component, so final x coordinate minus initial x coordinate gives you x displacement and final y coordinate minus initial y coordinate gives you y displacement. On the right hand side, This is initial velocity, but x component of initial velocity v0x into t plus 1/2, okay, as it is 1/2. A acceleration has two component, here x component of acceleration into t square. Similarly, y final y coordinate minus initial y coordinate gives you y displacement, that is right hand side v0yt plus 1/2 ay t square. So this equation can be written in terms of its component in this way. So these are the equation of motion. Now let's derive one more equation, especially from equation number 2, and look at the equation number 1. From the equation number 1, t is equals to what? Make it subject, as a subject. T is equals to v minus v0 upon a. V minus v0 upon a. Now this value of t, let's substitute this value of t here in this equation number 2. So now equation number 2 can be written in this way. Delta r is equals to v plus v0 by 2 into t. But now the value of t is v minus v0 upon a. V minus v0 upon a. Acceleration a. So therefore delta r is equals to, dear student, we know that a plus b and a minus b. We know that by a plus b, a minus b is equals to a square minus b square. According to that concept, v plus v0, v minus v0 is equals to v square minus v0 square. Denominator as it is 2a. So finally we can write in this way, v square minus v0 square is equals to 2a delta r. This is also the equation of displacement. Let's call it equation number C. Here all equations are the equations of motions, but remember this equation is applicable only in a two-dimensional motion with constant acceleration. Agar acceleration is not constant, then you cannot apply this all equation. Agar acceleration is constant and object performs two-dimensional motion, then this equation is applicable in that case. So now based on this discussion, using this equation, using this equation, using these equations, let's calculate a good sum from the textbook. So now based on the theory, let's calculate one of the illustration exercise. Not it's an exercise sum, but it's one of the illustration sum number 4.5, fifth illustration of the textbook, which is based on the previous discussion. Okay, let's read the question. A particle starts from origin. The most important information, starts from origin. We don't know the path, on which path particle is traveled, but that particle start the motion from the origin. And agar particle start the motion from origin, it means ke initial coordinates are 0, 0. Okay, initial coordinates x0, y0 are 0, 0. Initial coordinates 0, 0. Acha, so particles start the motion from the origin at t equals to 0 time with what velocity? That is actually the initial velocity, 5 caret meter per second. Initial velocity, vector sign 5 is the magnitude of initial velocity, I caret indicates that is in x direction, meter per second. From this is very clear that initial velocity has only one component. X component of initial velocity is 5 meter per second, whereas y component of initial velocity is 0. There is no term having j caret, only I caret is there. So initial velocity, x component of initial velocity 5, y component of initial velocity 0. Okay, after that it moves in a xy plane. Okay, particle performs, remember, two-dimensional motion with constant acceleration, and acceleration is also given to us. Acceleration is given to us 3I caret plus 2j caret meter per second square is the constant acceleration. From this also it is very clear that x component of acceleration is 3 meter per second square, y component of acceleration is 2 meter per second square. So these are the information carried out from the question. What they ask, what is the y coordinate of particle when its x coordinate is 84 meter? Means ke x displacement is 84 meter, at that time what will be the y displacement? Okay, Now let's recall the equation of displacement just before some time we derived. If you want to find x displacement, so final x coordinate minus initial x coordinate gives you x displacement v0 xt plus 1 half ax t square. So this equation just before some time we already derived in the topic. Okay, now final x displacement is 84 meter. Initial x coordinate is 0. X component of initial velocity 5 t as it is, 1 half as it is. X component of acceleration 3 t square. Okay, let's simplify. 84 is equals to 5t plus 3 by 2 t square. Let's take the multiplication. 84 2s are 168, 5 2s are 10t plus 3t square. Now this equation can be written in this way. 3t square plus 10t minus 168 is equals to 0. Now here we need to take the factors of this equation. Okay, we can write this equation in this way. 3t square acha plus 10t. Can I write minus 18t plus 28t minus 168 is equals to 0. 28 minus 18 gives you plus 10. So we divide this 10t into this way. 28t that is plus and minus 18. 28t minus 18t gives us 10t positive, that's why. Okay. Now from the first two term let's take 3t common, so into bracket t minus 6 plus, now from the next two term let's take 28 common, so again t minus 6 is remaining. 28 into 6 168. So here we have t minus 6 and 3t plus 28 is equals to 0. Remember, time never be negative. T minus 6 equals to 0 or 3t plus 28 is equals to 0. So t is equals to 6 second or 3t is equals to minus 28 means that t equals to minus 28 by 3 second. See, this is not possible. Time is never, as I said, time is never negative. It should be t is equals to 6 second. It means that when x displacement is 84 meter, initially particles start the motion from origin. Now we don't know on which path it performs the motion, but when after t is equals to 6 second, when particle reach here, its x coordinate is 84 meter at this time. At that time what will be its y coordinate? That is the question that we want to determine. Okay, so this is the equation of x displacement. Now let's use the equation of y displacement. Y displacement is y minus y0, final y coordinate minus initial y coordinate, y component of initial velocity into t plus 1 half ay t square. Okay, final y coordinate that we want to know, initial y coordinate 0. Now see here, y component of initial velocity is 0, y component of initial velocity 0, 0 into t 0 plus 1 half, y component of acceleration is 2, okay 2, and time duration is 6 square. We already get the time 6 second. So y is equals to, this term is 0, 2 and 2 cancel, 6 square 36 meter. It means, okay, as I'll say again, I'll repeat. In this example, we don't know, we are not able to know that by object performs the motion on which path. But just only one thing, that it start the motion from origin after 6 second. Particle suppose here its x coordinate is 84 meter. At that time its y coordinate is 36 meter is the y coordinate. Now second question is, what is the speed of the particle at this time? At this time means at this time 6 second. What will be the speed? Now dear student, this is the case of two-dimensional motion. Velocity has both component, x and y component. If you remember this equation, v is equals to v0 plus at. This equation can be written in terms of its component. Like x component is equals to x component of initial velocity, x component of acceleration into t. Y component of final velocity, y component of initial velocity, y component of acceleration into t. So let's first of all find the components of the velocity. Here x component of initial velocity 5, x component of acceleration 3, time duration is 6 seconds. 6 3s are 18, 18 plus 5 23 meter per second. So this is the x component of velocity. Now here y component of initial velocity 0, y component of acceleration 2, time duration 6, so that is 12 meter per second is the y component of velocity. These are the components of velocity, but we want velocity. So as per the old rule, Vx and Vy are the component. Try to recall the rule to find the magnitude of velocity. Square root of the square of the sum of the components gives the magnitude of velocity. It means under root of 23 square plus 12 square. If you simplify this, the final answer will be 26 meter per second is the velocity, speed of the particle at this time. At this time means at time t equals to 6 seconds. Dear student, the same one of the sum is present in the exercise part. I will tell you which one. We'll calculate after this. So this is the sum which based on the previous topic.